So, look at this cameras all set up. Like I feel like we have to remember where this class started. Like every class is like, oh, the camera's upside down. Let me set it up, see what's going on. Now it's like pretty perfect. Let's appreciate where we're at. The point is, we're still talking about sequences, and today a little bit of series. So let's get into it, which you might have went over in calculus. We should have gone over in calculus if you had any calculus teacher worth their salt. But we're gonna do it again because it's useful to us. So we're talking about section 5.1/5.6 sequences and series. All right, so remember that sequences we're going to do this every class are things that look like this. And actually, we're just going to look at infinite sequences from now on, because that's really what we're concerned about in math. I mean, finite sequences are a thing, but in math, we like the ones that keep going. So infinite sequences always have the form am plus 1, am plus 2, ... meaning so forth, on and on like that. Meaning they are ordered, indexed lists of numbers that never end. That's exactly what an infinite sequence is. It looks just like this. Now, this way to write it, I don't even think there's a name for it. Let's call it standard form / written out form, or / written form, because it's kind of like writing it out manually. There's that. But there's also the explicit form. This is a very nice way to write out sequences that goes like this. Another way to write this same sequence out would be to write AI equals f of I for all I greater than or equal to m. The thing to note being f is a function dependent only on I, where I is the index. So the way we write something in explicit form is we just write out, we just write what each term is in terms of with some function dependent on the index. So an example of that would be if we had the sequence AI, and what I should say is that I want to be very clear here that this explicit form, very clear here, I should actually pronounce it very clear here, this explicit form is equivalent, actually I want this in blue. The explicit form and the standard forms to write out form are, okay, if they represent the same sequence, are equivalent ways to represent the same sequence. I don't want to give the impression that, oh, this is the actual sequence and like this is just kind of like a shorthand or something like that, or this is the actual sequence and this is a longhand or a shorthand. No, there are two ways of writing the exact same thing. We'll see that right now. So for example, we've done things like this before. Let's have the sequence AI equal to, and actually, yeah, AI equal to I squared plus I for all I greater than or equal to 1. And by the way, I'll just tell you, we'll call this the explicit formula. And we'll call this the range. Because this is the formula that tells you what each term is, and this is the range of values we're considering. So here, our explicit formula that tells us what the ith term is in terms of the index I is this I squared plus I. This is the explicit formula here. And the range is for all I greater than or equal to 1. So we're starting at 1. And now an equivalent way to write this is just let's plug it in and figure out like what's the standard form of this. So we start at A1, which equals, because I is greater than or equal to 1, which equals, plug that in, we get 1 squared plus 1, which equals 2. Next we go to A2, which we plug the index 2 in, we get 2 squared plus 2, which equals 4 plus 2, which is 6. Or we could have A3, which plug the index 3 in, we get 3 squared plus 3, 9 plus 3 equals 12. On and on and on like that. Now, we've done this before. This is just how you go from explicit to standard form, right? You just kind of plug it in. The point is, the big point I want to get across is that these two things, these two representations here, are two equivalent ways to represent the same underlying concept. Oh, now we're getting philosophical. I almost said philosophical. The point being, let's look at it this way. Here. I think everything makes more sense if you look at it in terms of food. So look at chicken. Versus pollo. Which one is the delicious, flightless, domesticated bird? What do you guys think?
I think pollo is just chicken in Spanish. Well, I took Latin in high school, so like this is just a guess.
Wait, is there a Latin word for chicken?
Yo, that was too long ago. I can't tell you.
Did the Romans have chickens? Did they have cows? What did the Romans eat?
They definitely had cows. I remember memorizing the Latin word for ox. I can't tell you what it is right now though.
But it's ox the same thing as a cow.
Not really.
I have no idea what people ate back in the day. I feel like I have no idea what the Romans ate, but I feel like the medieval people were definitely eating chicken and cows. So I don't know when that happened. Anyway, I want to talk about this. Also, let's talk about the fact that they found some chicken bones in the west coast of South America that look like Polynesian chickens. So I guess like the Polynesian chickens, like the ancient Polynesians and the Indonesians, that area, what they had, are not the same chickens that like the Europeans had. And they found some chicken bones in South America that look like they're Polynesian chicken bones. And they dated them, and it was before 1492, which of course when the Columbus sailed the ocean blue. Meaning that possibly the Polynesians found South America. Who knows? The point is, Jordan Harmon, Soph, what do you guys think? Which one of these is the delicious, flightless, domesticated bird?
Neither.
I say neither,
both. Sorry, both.
Both?
Yeah.
Okay, so Safa says
Pollo is Italian for chicken, yeah.
So Spanish for chicken. Yeah, they're both the same
Something
thing.
like that.
So Toru votes they're both a delicious flightless bird. Safa votes. All I know about Safa is they took Latin. Herman, what's
Both
your
also.
What's up? What?
was your vote also both?
What was the question?
Yeah, both.
Okay. Here's the thing, and I feel like I'm gonna get a bunch of moans about this, but it's important. The answer is neither. They're both words. Neither of these are the delicious flightless bird. Like if you were hungry and I placed a solid CHICKEN on your plate, that wouldn't help you at all, right? Neither. They're both words representing the same concept. That's right, chickens are concepts. It's just deeper than I go in this class. But it's actually a lot like, I don't know how cultured you guys are, but if anyone's seen, where do I want to go? Now you see my research I've been doing. If anyone's seen this painting right here. Has anyone seen this? It's a cool little painting, and it says, I don't know, friend. Ceci n'est pas un pipe. Ceci n'est pas un pipe. Which means this is not a pipe in French. The point the guy was trying to get across is that this is not a pipe. It's a painting of a pipe, right? And we often get those things confused, right? We often like see a picture of an apple and go, that's an apple, but it's not really an apple, it's a picture of an apple, right? And we have the same thing happening here with the chicken case, right? These are not chickens, or these aren't the delicious domesticated flightless bird. These are words for them. But they both represent the same concept. And that's the same thing happening up here. It's all around our way to get back to this. The same thing happening here. This sequence that I'm trying to get across here, right, could be represented like this or represented like this, where really maybe you want to write it as 2, 6, 12, ... so forth on like that. They both represent the same sequence, but neither of them are the sequence. That's the weird thing. The sequence is kind of this conceptual thing that we're trying to write down here, right? But these are both representations, and so is everything in math. For example, this is not 3, right? It's the representation that we give to the concept of 3. And I would love to get into it. We're going to get into what we're going to get into what 3 means by the end of this class, or not this class, the end of this semester. I'm very excited about it. The point is, does that make sense?
Yeah, it's kind of like saying that musical notation isn't actually music itself. Like
Exactly, right? Yeah, exactly. Like you see music written out with the little cool like quarter notes and all that kind of stuff, and that's not actually music. Like, it's not gonna move you, whatever, maybe, you know what I mean? It's not gonna get you hyped for a football game, right? Like, I don't know what you guys listen to music for. But the point is, yeah, it's representation of music. Kind of the difference there though, Herman, is that I guess if someone actually played music for you out loud, you go, okay, now that's music, right? Math is a little slipperier in the sense that, I mean, where is the sequence? I said that these are both equally valid representations of the sequence. The sequence is kind of like the 3 thing. Like, where is 3? What would you look at and go, no, that's 3?
Well, would it be like a mental representation in your head? Like once you learn how to read mathematics, you could actually see the beauty inside your own mind, right? Something like that.
Yeah. I mean, I guess mathematical things really represent, the things we write down represents mathematical concepts that really only exist in our minds. That's a very weird thing, right? Like no one's ever observed 3. we can observe three things. These are three fingers. You look at these are three markers right here, but you know, but there's the abstract concept of three is impossible to be observed. It exists in our mind as a generalization. But we have different representations for it, and these are both different representations for the sequence. Anyway, yeah. The point is, the big point is, I don't want you guys to think that, oh, like this is a sequence and this is just kind of a weird way we describe the sequence. No, these are both equally valid ways to write the sequence. These are both equally valid ways to define a sequence. It's both defining this mental concept. By mental, I mean of the mind, and also like freaking mental, man. Cool. That got deep for a second. I didn't want to erase that. Oh well. But anyway, so yeah, that's just a little tangent there about sequences.